Hello, I've got a really nice induction question here. It's quite interesting the way it works out. It took a while for me to see it, but it's not too difficult mathematically. It's more just the logistical thinking of it and how you approach the question. So I'm just going to walk through my thought process when solving it, and hopefully you learn a thing or two along the way. So first step of induction, as you know if you've seen my previous video, which if you haven't, I'd probably go back and look, because that actually talks about the basics of induction with a much more simple problem, and so it's easier to wrap your head around instead of just diving right into it. But by all means, if you feel like you can keep up, then stay along for the ride, and those of you who are smarter than me will for sure just be able to understand this as we go along. So our first step is prove true for n equals 1. Now we're going to work one side at a time for this first step, as we always do. Our left hand side is equivalent to 2 times negative 3 n minus 1, sub in our 1 for n, 2 times negative 3 1 minus 1, which is of course negative 3 to the power of 0, which is just 1, and so we just get 2. Now right hand side equals 1 minus negative 3 to the power of n over 2, which equals 1 minus negative 3. Sub in our 1 for our n, equals 4 over 2 equals 2. Now just a note on this step between these two, it's important to note the reason we're making it positive is because here's a negative and they're multiplying to make a positive. This could be rewritten as 1 plus negative 1 times negative 3 over 2, right? And these are two, as I pointed out earlier, this is a negative number, this is a negative number. So when they multiply, they create a positive. Positive 3, 1 plus positive 3 is 4. Just in case you got confused over there, because I actually did the first time I was working through it. I was thinking, how on earth does that happen? And oh, here I am erasing all my working out as well. There we go. Much nicer. So, got that all sorted, hope you understand. And since that's both equivalent to 2, left hand side equals right hand side. I just like to make a little note of this over here, just to show that you do understand that they're equivalent, and that's why you're moving on to the next step. Step 2 is assume n equals k. Now, a better way of saying this is actually assume true for n equals k. I might actually rewrite that, because that's technically the more correct version, and don't want to be corrected by anyone. No one really does, so there we go. And then step 3, we've got prove true for n equals k plus 1. Absolutely shocking handwriting going on over here, but we can see the point. Now for these two steps, I'm just going to write out the equation, what it looks like in these cases. So 2 minus 6 plus 18 minus 54 plus dot 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 plus 2 negative 3 and oh, not then. That's actually the difference. K minus 1 equals, now this step might seem really unnecessary, but it helps a lot later on, as I showed in the last video, so I don't really want to skip it. And as I always like to do, I'm going to pick a much nicer color. Pink's a bit harsh on the eyes, or at least that pink. My girlfriend will get very upset with me if I call pink an ugly color. Pick a nice blue over here, and move on. Now I just highlighted that for later, and you'll see why. Now I'm going to copy this down, basically the same thing. 2 minus 6 plus 18 minus 54 plus dot 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 plus 2 times negative 3 k minus 1 plus the term afterwards k plus 1 to negative 3 k plus 1 minus 1. And technically you can just get rid of that, but we're just going to leave it for now, just to leave it for a later step to make it a bit more clear. Equals 1 minus negative 3 k plus 1 over 2. Alright, so that's our full equation. And now we're just going to work with the left hand side, so this side over here. And we're going to try to get it to look like this side over here. And that's how our proof is going to work out. So, first things first, what I'm going to point out is that this blue section, which I just highlighted, it actually looks identical to the blue section I highlighted up there. And so what we can do is replace it with the right hand side that's shown up there, which takes down a lot of the information to a much more condensed, neat little equation. But also, it takes out this series between here, this unknown, and turns it into a known, other than this little k up here, obviously. So we're just going to rewrite that down. So left hand side equals 1 minus negative 3 to the k over 2 plus 2 negative 3 k plus 1 minus 1 equals, now we're just going to get rid of the drawing up here, this plus 1 minus 1, as well as making the denominators the same. So to make the denominators the same, we can multiply this bit here by 2 and just divide it by 2 as well in the same line. So 4 times negative 3 to the k, because we're getting rid of that plus 1 minus 1, divided by 2. Nice and simple. And now just for readability, we can also plus 4 negative 3k over 2. We can just combine them into one big fraction. So what does this actually mean? Well, the easiest way of looking at this, in my opinion, is just thinking we need to try get it to look like this up here. Let me just grab another color. We need to get it to look like this up here. So what are the differences holding us back at the moment? Well, we've got a 4 up there, and we've got the k up here instead of k plus 1. So first things first, let's get rid of the 4, which is a much easier way. If you're looking at this entire section here, you can simplify it down to negative x plus 4x, where x equals negative 3k, right? Because this variable actually remains the same between all of these. So delete that. We're going to simplify this down. 1 plus 3 times negative 3 to the k over 2. Now, what's our problem? Well, we need a negative sign in this little bit here instead of a positive, and we need that 3 to go away and go up to the k. Well, if we rewrite this, I think you'll be able to see it for yourself actually what we have to do. 1 plus see, if you look at it now, I think it's a lot easier to visualize what you're supposed to do. That step just here takes a fair bit of practice and maybe some additional help from a friend or from a teacher, but once you get your head around looking at the problem in a certain way, you can see it fairly quickly actually, and as you can see, the mathematics of it isn't too hard. So for all of you that don't understand yet, no problem with that, just need a bit more practice. All that we've done is split this 3 up here into -1, -3, which of course multiplied to equal the same thing, so we haven't actually changed the value in any way, which would of course make it invalid. But what we have done is made it a bit more clear to see, because now the -3, due to indice laws, can be multiplied up. Oh, sorry. -1 times -3, k plus 1. This little section here is, of course, a result of indice laws in the case of a to the 1 times a to the b equals a to the b plus 1. Right? And that actually works for a instead of 1 is the correct way of writing it out, but we're just using 1 in our case anyway, so I'm not really going to bother rewriting it. Now that we've got that, just erase this highlighting. Go down over 2, and finally, to simplify it out, we don't need a plus and a -1 next to each other. We can just say minus -3 k plus 1 over 2 equals right hand side as required. Nice. Now, a fair bit of working out, but it is absolutely beautiful mathematics. It all works out very nicely. Lovely little problem. And see you in the next